Okay, so for today's presentation, we're gonna be dealing with trigonometric functions at any angles. Yet, there are these angles which are considered to be special. Okay, so these are the 30-degree, 45-degree, and 60-degree angle. Why are they so called special angles? In such a way that it was discussed in geometry that those triangles with angle measures of 45, 45, 90, and 30, 60, 90 are considered to be special triangles. Now, in trigonometry, we're gonna use that relationship to evaluate the trigonometric functions of a 30-degree, 45-degree, and a 60-degree angle. Okay? So, for example, we'll consider an equilateral triangle wherein all the sides here are congruent. Now, if we are going to draw a perpendicular line from one vertex to another, then that would make one of the sides, or that would make the measure of the side opposite to the vertex half. Okay, meaning to say, we will consider this part of the triangle as the hypotenuse. This would be the abscissa, and this would be the ordinate. Meaning to say, the hypotenuse would be, let's say for example, that is 2, then the abscissa would be 1. So our main problem here is the length of the abscissa. So let us now put that into Cartesian plane. So let us have this to find the trigonometric functions of a 60-degree angle. So going back, if we have an equilateral triangle, meaning to say they are also equiangular, meaning to say all angles measure 60 degrees. That is why this is 60 degrees. This is also 60 degrees, and this is also 60 degrees. But the moment we draw a perpendicular line here, meaning to say this perpendicular line serves also as our angle bisector, which divides the angle into two congruent parts, meaning to say this angle, the measure of this angle would be 30 degrees. Okay, so let us now try to find the trigonometric functions of this triangle prior to 60-degree angle. So let us have this. So let us put down there into a Cartesian coordinate system. Okay, so here, tulad ng sabi natin kanina, the hypotenuse would be 2, or the value of r would be 2. Our abscissa would be 1, and then our main problem here is the length of our ordinate. Okay, so we have discussed from our to your geometry class that the measure of the one of the legs of a 30-60-degree angle would be what? Would be a square root of 3, the measure of one leg multiplied by the square root of 3. So if this is 1, then definitely our ordinate would be equal to the square root of 3. So meaning to say, point P here would have a coordinate of 1, 3, where the abscissa is 1, and then the ordinate is square root of 3. Okay, so this is just a relationship that we have derived from our geometry class. Okay, so now, let us now try to derive the trigonometric functions of special angles wherein we consider a 60-degree angle. Okay? But first, let us have a review of the trigonometric functions of any angle. We have here the sine theta would be equivalent to ordinate over hypotenuse. Cosine theta is abscissa over hypotenuse, and tangent theta is ordinate over abscissa. And then the reciprocal functions would be obtained by reciprocating the three basic trigonometric functions. So let us now try to find or to look for the trigonometric functions of special angles considering a 60-degree angle. So meaning to say, our value of x, the value of our x would be what? The value of our x, or the abscissa, would be 1, and then the value of our y, or the value of our ordinate, would be square root of 3. That would be square root of 3, and then the value of r, or the value of the hypotenuse, would be 2. So with this given, we're gonna be having, or we will be able to determine the different trigonometric functions of the 60-degree angle. Okay. In finding trigonometric functions of special angles, it is same with this one. Okay. We just consider those angles special in such a way that they have special relationship with their sides. Okay, so let us now try to find the first function, which is sine theta. So sine theta, as we all know, that is ordinate over hypotenuse. Meaning to say, the ordinate is square root of 3 and the hypotenuse is 2, meaning sine theta would be equivalent to what? To square root of 3 over 2. Okay, so that will be our first trigonometric function. Next, we have the cosine theta. We all know that the cosine theta, or the cosine 60, so let us just name the theta 60 because we already have our angle measure. So the sine of 60 degrees, it would be square root of 3 over 2. And then let's proceed to the next one. We have the cosine of 60 degrees. We all know that the cosine function of any angle would be equivalent to abscissa over hypotenuse, wherein our abscissa is equivalent to what? 1. That would be 1 over 2. Alright? Or our cosine 60 would be 1/2. Okay? Next, we have the tangent function, or the tangent of 60 degrees. The tangent of 60 degrees would be equivalent to ordinate over abscissa, and that would be equivalent to, our ordinate is 1 over abscissa, or sorry, square root of 3. Our ordinate is square root of 3 over abscissa, which is 1. And if we simplify this one, the tangent of 60 would be equivalent to just square root of 3. And then, the three other trigonometric functions would be obtained by reciprocating the first trigonometric, or the first three trigonometric function. So we have the cosecant of 60 degrees. The cosecant of 60 degrees would be equivalent to the reciprocal of sine of 60. That would be what? That would be 2 over square root of 3. Okay? Or, since we have a radical sign on the denominator, what we're going to do is to rationalize it by multiplying both sides by square root of 3. So, if we simplify that, or if we multiply that with the conjugate, which is square root of 3 over square root of 3, sorry. Alright, we are to multiply it with this conjugate. That is square root of 3 over square root of 3. Sorry. Alright. And that would be what? And that will yield to 2 square root of 3 over 3. That would be equivalent to 2 square root of 3 over 3. So that would be the cosecant of 60 degrees. Okay? Next, we'll be having our secant of 60 degrees. So the secant of 60 degrees would be equivalent to the reciprocal of cosine. That would be hypotenuse over abscissa. Okay, so that is 2 over 1, or simply we have 2. And the last one would be the cotangent of 60 degrees. The cotangent of 60 degrees is equivalent to the reciprocal of the tangent 60. That would be what? 1 over square root of 3. Again, we have to rationalize it since we have a radical sign on the denominator. So we are to multiply it with its conjugate. So that would be 1 over square root of 3 multiplied by square root of 3 over square root of 3. Okay, and that will yield to, that will yield to square root of 3 over 3, or simply 1 times square root of 3, that is square root of 3 over square root of 3 multiplied by square root of 3, that will yield to 3. So meaning to say, the trigonometric functions of special angle 60 degrees are as follows. Sine 60 would be square root of 3 over 2. Cosine 60 is 1/2. Tangent 60 degrees is square root of 3. Cosecant of 60 degrees would be 2 square root of 3 over 3. The secant of 60 degrees would be 2. And last one, the cotangent of 60 would be 3 square root of, or square root of 3 over 3. Okay? So, all angles coterminous with 60 degrees, again, all angles coterminous with 60 degrees would have these trigonometric functions. Okay, so 60 degrees is just one of special angles. So other special angles would be the 30-degree angle, wherein you may ask me, sir, is 30-degree angle included here in this concept? No, because here we are dealing with the trigonometric functions prior to 60 degrees. Now, if we will have a 30-degree angle, then this would become 30-degree angle, and the coordinate of P would be not the same with that of 60 degrees. So, kapag naging 30 degrees na po ito, iba na po yung coordinate ni P. So, ibig sabihin, iba na si abscissa at saka iba na rin po si ordinate. Okay, so this will just interchange. Okay, again, any angles coterminous with 60 degrees will have a trigonometric functions just like this one. So let us try using the calculator if these are correct. Let's say, for example, we have the sine of 60 degrees, so that would be what? That would be square root of 3 over 2. Okay, that's a fact. Okay? So, sir, tulad ng sinabi mo kanina, so all angles coterminous with 60 degrees would have the same trigonometric functions. So, let's have give me an angle that is coterminous with 60 degrees. So, let's say, for example, a positive rotation. So, we had to add 360. So, that's 420 degrees. So, let us try to find the trigonometric function, or let's say, for example, the sine function of 420 degrees. That will still be square root of 3 over 2. So that is always, or again, trigonometric functions coterminous with 60 degrees will have the same trigonometric function values with that of the 60-degree angle. Okay? After discussing the trigonometric functions of special angles, another angle which is very special is what we so-called quadrantal angles. So what are quadrantal angles? So quadrantal angles are angles wherein the terminal side lies on either the positive or negative x or y axis, meaning to say they have exact measure of either 90 degrees, 180 degrees, 270 degrees, or 360 degrees, and any angle coterminous with those. Okay? So, we will have the trigonometric functions of the different quadrantal angles by defining it using the definition we have derived from the trigonometric functions of any angle. But in this case, we're gonna be discussing it in light with the what we so-called unit circle. So let's say, for example, we have a unit circle here. So tulad ano ba si unit circle? Unit circle is a circle plotted in the Cartesian plane wherein the radius is 1. Okay? Let's say, for example, we are considering 90 degrees. It is considered to be a quadrantal angle in the sense that its terminal side coincide with the positive y-axis. Okay? So this is what we so-called quadrantal angle. Alright. It is neither on the first quadrant or the second quadrant, but it's on the y-axis or the positive y-axis. So meaning to say, if we have a unit circle here, the coordinates of P would be what? That would be 0, 1. Ibig sabihin, 0 po yung abscissa dahil wala naman po tayong movement from the x-axis, and then we have 1 unit to our ordinate. Okay? So let us now try to derive or to find the trigonometric functions of quadrantal angles. Okay? So, it's, again, tulad ng sinabi ko, it's the same with the trigonometric functions of any angle that we have defined from our previous discussion. Okay? So, now, if we have P at 0, 1, meaning to say the value of x would be 0, the value of y or our ordinate would be 1, and our problem here would be what? Would be the measure of our r or hypotenuse. Sir, may hypotenuse po ba dito? Yes, meron pa rin. Though, eto siya, eto. So, from this point up to this point. So, how are we going to, um, to find for the value of of our hypotenuse? So, that is still using our, what do you call that? Our Pythagorean theorem, wherein the value of r, or yes, the square of the hypotenuse is equal to what? It's equal to the sum of the squares of the two other legs. So that would be r square equals x square plus y square, plus y square. Okay, but since we are just dealing with, or we are just after the measure of r, then we can extract the root of both sides. In finding r, that would be what? The square root of the x square plus y square. Okay, by just substituting the values we have here, since the value of x is 0 and the value of y is 1, so that would be 0 square plus 1 square. And by simplifying this one, we have r equals the square root of 0 plus 1. Okay, that would be square root of 0 plus 1. And simplifying what is to be simplified, so that is adding 0 and 1, that would be r equals the square root of 1. And if we extract the square root of 1, that would be equivalent to 1, meaning to say the radius would be 1. Okay, so in finding, since we already have the three coordinates, the x, the y, and the r, then we'll be able to what? To find for the different trigonometric functions. Okay, so let us have the first one. Let us have the sine of 90 degrees. The sine of 90 degrees. Again, sine function of any angle, that would be equivalent to ordinate over hypotenuse. So our ordinate is what? Our ordinate is 1 and our hypotenuse is 1. So meaning to say, sine 90 would be equivalent to 1 over 1 or simply 1. Okay, and then we have the cosine of 90 degrees. That will be the cosine of 90 degrees. We have abscissa over our hypotenuse. That is abscissa over hypotenuse. So we have our abscissa is 0. Our abscissa is 0 and our hypotenuse is 1. And by simplifying this one, 0 over 1 is still 0. Okay? Next, we have the tangent of 90 degrees. The tangent of 90 degrees. Okay. Sorry. Alright. Just a bit. So that is tangent of 90 degrees. And tangent of 90 degrees would be equivalent to, from our definition, that is ordinate over abscissa. Okay, so our ordinate is 1, the value of our ordinate or the value of y is 1, and our abscissa is 0. So that is 1 over 0. And from our definition of fraction, if we have a 0 denominator, then that would be impossible to exist. So that would be undefined. Okay, so the tangent of 90 would be undefined. Okay, next, the other three reciprocal functions would be obtained by reciprocating the three basic trigonometric functions. The first one is the cosecant of 90 degrees. So that would be equivalent to the, what do you call that? To the reciprocal of sine. That would be still 1 over 1. That will be 1 over 1 or simply 1. Next, we have the secant of 90 degrees. The secant of 90 degrees would be equivalent to the reciprocal of cosine 90. That would be 1 over 0. That would be 1 over 0. And if we simplify that, then that is impossible to exist. So that would be undefined. Okay, and the last one would be the cotangent of 90. The cotangent of 90 degrees would be the reciprocal of the tangent of 90 degrees. So that would be the reciprocal of tangent, that is 0 over 1, or simply that is 0. So these are the different trigonometric functions of a quadrantal angle, particularly a 90-degree angle. Okay? So same thing goes with other same thing goes with other quadrantal angles. Same thing goes with 180 degrees and 270 degrees, and so with 360 degrees. And any angle coterminous with those angles will have the same trigonometric functions. Okay? But tulad ng sinabi ko, since these are quadrantal angles, there would be you have to take into consideration the different signs of the coordinates of P, so that you will have correct sign for your trigonometric function value. So let us double check. Let's say for example, we have the sine of 90 degrees. We have the sine of 90 degrees. So that would be equivalent to, that would be 1. Okay? But what if we have the sine of 180 degrees? The sine of 180 degrees meaning to say your abscissa is negative 1. Okay? So that would be 0. Let's say for example, what function would consider the abscissa? That would be the cosine. So the cosine of 180 degrees, let's say for example, that would be negative 1, since the abscissa of 180 degrees is a negative number. Okay? So you have to take that into consideration. So that would be the trigonometric functions of quadrantal angle.